can draw. But I don't want to draw 7 all over again. So it's a quicker way I can draw. Ooh, I'm seeing some friends are getting it. Those aha light bulb moments are coming on. Joanne, what's a quicker way that I can draw these insects?
You could only like write 4 circles and the other few that are on the top, just add them to the left word.
Right. I can just draw 4 circles, Jorge, and add them with the 3 I have on top to get those 7 insects. So let's do that now. And I promise, scholars, hopefully some friends can share an easier way to solve it so we're not drawing circles for 15. So go ahead and draw 4 circles. And how many legs go in each circle?
7.
How many?
6.
Scholars. How many legs go in each circle?
4.
6.
6.
1, 2, 3, 4, 5, 6. 4, 5, 6. Okay, so I have 7. So I have 7 total now. So what can I do next? What can I do next to solve this problem? Thanks for having your hand up every time. What can I do next to solve this problem, Alex? I can skip count as a strategy? Yeah. So when I skip counted before, it looks like I counted by my 6, 12, 18. I stopped at 18. What's after 18?
24.
6. Oops, wrong one. All right, scholars. Let's count by our 6s 3 times.
6, 12, 18, 24, 30, 42.
Huh. So all we have to do is keep going back. Right. 6, 12, 18, 24, 30, 36, 42. Write down with me and I will let you go. So, then how would my multiplication equation look like? Natalie? 7 times 6 equals 42 legs. Right. 7 times 6 equals 42 legs. There are 42 legs on 7 insects. There are 42 legs on 7 insects. Right. So, scholars, I'm not sure what's going on. We're meeting our energies all going in math. So I'm going to give you 1 minute to take a break. We need to readjust.
Jack didn't let me use the bathroom. Okay.
We had our break. Let's readjust and going back into math. Okay, so we found out how many legs are in 7 insects. Now comes the hard part. How many legs are on 15 insects? So just like before, this time what I would like you to do, scholars, is talk to your back to front buddy, only talking through what we can use to solve this problem. And I'll be listening out for that strategy that is efficient to solve this problem. I will give you 2 minutes to discuss with your buddy.
I
Go.
think that distributed property.
So you're not solving, just talking. So we're just talking Don't stop. Keep going. Or scholars, give me a thumbs up if you're ready to discuss. Thumbs down if you still need to talk a little bit more. Thumbs in the middle if you might need a bit more time. Okay. All right, keep going. So when you start, you're okay. But remember, you're only supposed to talk about how we can solve it. Don't solve it just yet. Just talk about how we can solve All right, scholars, come back together. 5, 4, 3, 1, 0. So, no wait. I want to talk about what you did with your work. Because your strategy looks a lot like my super secret strategy that I wrote up on the board yesterday. So tell me what you did. Scholars, pay attention because this one strategy is going to help you.
Okay, actually I have a name.
It has a name. What's it called?
Distributed property.
Distributed property. Scholars, what's it called?
Distributed property.
It's called distributed property, Alex. And what did you do in distributed property, Noe?
I put 6 and 15.
You put 6 and 15.
I split it at 15 into 10 and 5.
You split the 15 into 10 and 5. Huh, it's kind of like decomposing. Okay?
And then I multiplied 6 times 10, that got me to 20.
And no wait, I hope you don't mind, but I'm going to write what you multiply on the side here because it helps my brain better. And that got you to what?
60.
It got you to 60. Okay.
Then I multiplied 6 times 5. And that got me to 30.
And it got you to 30.
Then I just added 60 times 30.
If you're adding, what are you doing? Not times.
Plus.
So you just added 60 plus 30.
And that got me to 90.
So how many legs are there on 15 insects?
90.
90 what?
90 legs.
Oh! So you mean if I kept double check if no way's right. You have your 100 charts. Look on your 100 charts. Is 6 times 15, 90? Do a quick double check.
Yes. Yep.
Look on your 100 charts, making sure that 6 times 15 is 90. That no way is right. All right, scholars, freeze. Freeze. So, Kaylee, I see you have your chart out. Is Noe right?
Yes.
He's right. How do you know?
Because I looked at the number 15 where they count by sixes and it says 90.
Can I borrow your 100 chart to show the class? So Kaylee looked at her multiples of 6, Braulio, and she looked where it said 15 times 60, and look at that, it equals 90. And scholars, if I were to look, there it is, 90 is one of our multiples, so Noe's right. This strategy got us to our product a lot faster than drawing the strategies out. Great job, Noe. Thank you for introducing us to distributive property. Scholars, to do a check for understanding, please turn to your side-to-side buddy and share what did Noe do to solve this problem. So show it on your board too, so that we remember how it looks like. Alright, scholars, come back together in 5, 4, 3, 2, 1, 0. Right, I heard a lot of scholars say he used distributive property. Good. So, what I would like to do now is let's look back at our crazy problem that we wrote about when we had to draw the 19 cuts. Okay? You have it on your sheets, if you can't read it. So, let's focus on the final problem from the first. Let's focus on the third problem from the first problem. So basically we're focusing on 26 cuts and finding out, Evan, thanks for your eyes, how many legs there are in all. I use distributive property as my super secret strategy. How did I start that strategy? What were the things that I did? How did I start that strategy, that distributive property that we just learned? How did I start it? What was the first thing that I did? Alex? I split the bigger number. Right. So I have 4 and 26, and I split the bigger number into what and what? 20 and 6. I split it into 20 and 6. Right. What did I do after that? After I split my number?